All right, so we are looking at select questions from the Unit 4 Chapter 6 review. So I'm going to go through select problems. So if you're struggling to solve some of these, this might help you set them up and or solve them. So let's talk about question 1. We've got a system of equations here that we've been asked to solve by graphing. You've got 2y plus x equals 10 and y equals 3x minus 2. The first equation is not in slope-intercept form, but the second one is. So before we do anything else, let's go ahead and rewrite this first equation in slope-intercept form. So we're taking 2y plus x equals 10. The first thing we want to do is move the x to the other side by subtracting it. So that's going to give us 2y equals negative x plus 10. From here, we'll then divide by 2 to undo the 2 on the y. And so our slope-intercept form equation becomes y equals negative 1/2 x plus 5. This is the equation we now want to graph. We're going to plot our y-intercept at 5 first. And we're going to apply our slope. Down 1, right 2. Down 1, right 2. And we're going to keep doing this until we have enough points. And since we're trying to solve a system, we're looking for where the two lines are going to intersect. So the more points that we have, the better. And so here's our first line. And so now we're going to switch up and we're going to graph the second one, which is also already in slope-intercept form in this case. So we're going to start by plotting our y-intercept at negative 2. And we'll apply our slope. Up 3, right 1. Up 3, right 1. Up 3, right 1. And so on. And at this point, we probably have seen where these two lines cross. But I'll go ahead and finish graphing it just so it looks nice. So in this case, we're looking for the point of intersection because that's going to represent the solution to our system. In this case, that point is right here. That is the point 2, 4. All right, let's look at question 2. Same thing, solve by graphing. So we want to have these so they're easy to graph. So let's graph them from slope-intercept form. So for the first equation, we've got 2x plus y equals negative 4. I'm going to subtract the 2x to the opposite side, so that way I have y all by itself. Oops. So we're going to get y equals negative 2x minus 4. I'm going to plot my y-intercept at negative 4. And then I'm going to apply my slope. Down 2, right 1. Down 2, right 1. Down 2, right 1. I can then go the other direction. Up 2, left 1. Up 2, left 1. And I'm going to do this until I have enough points to define my line. Our second equation is currently written in point-slope form, so we can simplify this like we did in the previous chapter. We'll do that by distributing our slope first. So now we've got y minus 1 equals 1/3 x plus 2. Then we're going to add 1 to both sides to get y all by itself. So y equals 1/3 x plus 3. So for this one, we're going to graph our y-intercept at 3 and apply our slope. Up 1, right 3. Up 1, right 3. Up 1, right 3. We can then go back to the y-intercept and go the opposite direction. Down 1, left 3. And now at this point, I can see where my point of intersection is, and I now know where my solution lies. So in this case, the solution to this system is this point of intersection right here, which is the point negative 3, 2. And so that takes care of the solving by graphing for this section. I'll leave number 3 for you to practice if you want to try that one. All right, and so now let's look at the next set. Solve using substitution. We're going to start with question 4. And in question 4, we already have one of our equations solved for an individual variable. We have y equals negative 3x plus 18. So we know that this quantity here is what y equals. So we're going to substitute this quantity in for y in the second equation. So we can go ahead and rewrite that second equation. It's going to be 4x equals 3 times negative 3x plus 18 minus 2. We've replaced y from the first equation in for y in the second. So now we're going to use our algebra rules and we're going to solve this. We're going to distribute the 3. So this is negative 9x plus 54 minus 2 equals 4x on the other side. We'll clean up some like terms here. 4x equals negative 9x plus 52. I'm going to bring the 9x to the other side, so I'm going to add 9x. So that's 13x equals 52. I'm going to divide by 13. And I should get x to equal 4. Now that I know what x equals, I'm just going to plug it back in order to find y. And I'm going to plug it back into that first equation. So that means I'm going to get y equals negative 3 times 4 plus 18. Negative 3 times 4 is negative 12. Plus 18 is going to give us 6. So y equals 6. So our solution here is the point 4, 6. Question 5 is very similar, except neither equation is currently written or solved for a single variable. But the first equation is actually pretty easy to solve for x. We have x minus 2 equals negative 6y. To solve for x, I'm going to add 2 to the other side, or to both sides. I then get x equals negative 6y plus 2. This is what x equals. I'm going to take what x equals in this equation, and I'm going to plug it in for x into the second equation. So now I'm rewriting that second equation. Negative 2 times negative 6y plus 2 plus 8y equals 16. I'll then distribute the negative 2. So that's 12y minus 4 plus 8y equals 16. Combine like terms. So 12y and 8y, that's 20y minus 4 equals 16. I can then add 4 to both sides, and I'm going to get 20y equals 20. I can then divide by 20, and I should get y equals 1. Now that I know what y equals, I'm just going to plug it back into one of the equations. I'm actually going to plug it back into the one I rewrote. And so if I plug that back in there, I end up with x equals negative 6 times 1 plus 2. Negative 6 plus 2 is a negative 4. So that means my solution in this case is the point negative 4, 1. And in this case, this is solving by substitution. So we should be okay here. I'm going to leave number 6 for you to try on your own. In this case, it is already solved for y in the first equation, so you're substituting y into the next. All right, let's look at the next set. In the next set, we're talking about using elimination. So elimination, remember the key here is that when you combine straight down, one of the variables should cancel out or zero out. If it doesn't, then that means you have to multiply one or more of your equations by something to change them. So in the first problem here, question 7, I've got 6x plus 4y equals 42. And then I've got negative 3x plus 3y equals negative 6. None of the variables have the same coefficient number but different signs. But I can probably manipulate this second equation so that way that this negative 3x becomes a negative 6x and cancels with the other one. To do that, I need to multiply the second equation by 2. So I'm going to leave the first equation as it is, so I'll just rewrite that here. 6x plus 4y equals 42. The second equation, however, I'm going to multiply everything in it by 2. So this becomes negative 6x plus 6y equals negative 12. I can then eliminate straight down or combine straight down. 6x and negative 6x become 0. 4y and 6y are going to become 10y. And 42 and negative 12, that's going to give us 30. We're then going to divide by 10 to solve for y, and so y equals 3. Now that I know what y equals, I just need to plug it back into one of the equations to solve for x. So it doesn't really matter which one you choose. I'm going to plug it back into the very first equation. So 6x plus 4 times 3 equals 42. So this becomes 6x plus 12 equals 42. I'll subtract 12 from both sides. You get 6x equals 30. And so in this case, x equals 5. So your solution here is the point 5, 3. A similar situation occurs in question 8. We have x plus 2y equals negative 1, and x minus y equals negative 4. Right now, none of the items have differing signs where they're going to cancel out, but if we wanted to, we could probably cancel the x's in this case by just multiplying one of the equations by negative 1, or if we want to cancel the y's, we could multiply the second equation by 2, which would make it a negative 2y. So we have options. There's different ways to do this. I'm probably just going to multiply, let's say I'm going to multiply the first equation by negative 1. So I make this negative 1, so I'm changing the equation. So it's going to become negative x minus 2y equals 1. I multiply everything by negative 1. And so now I've changed it, so I don't really need to worry about this equation anymore. And I've got my two equations here. Now I can eliminate straight down. Positive 1x, negative 1x is just 0. Negative 1y, negative 2y, that's negative 3y. Negative 4, positive 1, that's negative 3. I'll then divide by negative 3 on both sides, and I get y to equal 1. Now that I know what y equals, I'm going to plug it back into one of the equations. I'm going to plug it back into that second one. So I'm going to have x minus y, which is now 1, equals negative 4. I'll add 1 to both sides, and I get x equals negative 3. So my solution to this problem is the point negative 3, 1. I'll leave question 9 for you to try on your own. All right. Question 10, we've got a word problem. It says, at a bakery, Riley bought 3 bagels and 2 muffins for $7.25. Karen bought 5 bagels and 4 muffins for $13.25. What is the cost of each item? So in this case, we're looking at writing an equation. We're going to write one equation for what Riley bought, and then we're going to end up writing one for what Karen bought. So as we look through what we're reading, we'll read through. Riley bought 3 bagels and 2 muffins for a total of $7.25. The things we don't know in this case are the price of the bagels and the price of the muffins. So we'll let the variable for bagels be B, the variable for muffins be M. So Riley's got 3 bagels plus 2 muffins equals $7.25. Karen then bought 5 bagels, 4 muffins for a total of $13.25. So we're looking at an equation like 5b plus 4m equals $13.25. This problem, because the variables are aligned in the way we set up the equation, is probably best suited for elimination. To solve using elimination, we've got to figure out how to get one of the variable sets to cancel. And the easiest way to do this would probably be to multiply this first equation by negative 2. That's going to turn the 2m into negative 4m, which is going to allow things to cancel. So I'm going to go ahead and change this. This is going to become negative 6b minus 4m equals negative 1450. The second equation, we've got 5b plus 4m still. We didn't change anything here. 13.25. Now that we have this changed, things align and we can eliminate straight down. Negative 6b, positive 5b is a negative 1b. The m's become 0 because they cancel out. And then here we get a negative 125. So then to solve for b, we'll divide by negative 1. And we get that bagels in this case cost $1.25. Now that we know the cost of bagels, we just need to find the cost of muffins. So we can plug this back in and solve for muffins. So let's say we go back to the original first equation before we changed anything. We've got 3 times 1.25 plus 2m equals 7.25. 3 times 1.25 is 375 plus 2m equals 7.25. We'll subtract the 375 over. That's going to give us 350 equals 2m. We can then divide by 2. And we're going to get the cost per muffin in this case is $1.50. So bagels cost $1.25, muffins cost $1.50. Actually, I lied, not $1.50, $1.75, sorry. I messed up my math there. All right. Question 11, graph the linear inequality. So in order to graph this linear inequality, we have to get this into slope-intercept form. So we've got x plus 3y is less than or equal to 12. We're going to move the x to the other side, so we're going to subtract x from both sides. We've got 3y is less than or equal to negative x plus 12. We're then going to divide by 3. So y is less than or equal to negative 1/3 x plus 4. So now we're going to graph this inequality. So to start with, the first thing we have to do is plot the y-intercept because it's now in slope-intercept form. So our first dot is going to go at 4. And we're going to apply our slope. Down 1, right 3. Down 1, right 3. And then if we want to go back, we can go up 1, left 3, up 1, left 3. Because of the inequality symbol being equal to this symbol here, this means it's going to be a solid line. So we're going to go ahead and draw a solid line to connect our points. Since we are dealing with the less than symbol, that means we would shade underneath or below. So shading below this means we would be shading to this side of, the line. So everything in this region is going to get shaded because this is the solution region to our inequality. Every point in this region is a solution to this inequality. All right, and then we'll look at question 12. So question 12 is kind of reverse engineering the inequality that this graph represents. In order to do this, we first need to figure out our y-intercept as well as our slope. So in this case, our y-intercept should be this point here, which is negative 3. Our slope is easily found by finding 2 clearly defined points. So we've got one here and one here, and then we're going to count the rise over the run. So we're going up 1, 2, 3. So up 3 over 1, 2, so 3 over 2. And so now we're just going to start building our inequality. We know that it's 3 over 2x minus 3, and then we know y is here, but we've got to figure out what inequality symbol has to go here. Well, it's dashed, so it's got to either be less than or greater than, but not equal to. And then they shade it above, so it's then, by default, automatically has to be the greater than symbol. So this would be our linear inequality.